this video clip, we want to work on the domain of the given functions. Here they all are logarithm functions. For the logarithm function, the expression behind the log sign has to be positive. You may write here the expression behind the log has to be positive. Why? We have a 2 to the negative 3 is 1 over 2 cubed is 1/8, which is greater than 0. And then we have a 2 to the 0 is greater than is 1. Which is still greater than 0. And then we have a 2 cubed is 8, of course, they're all greater than 0. And you can see here, this one, they're all positive. All positive. And then the corresponding logarithm is what? We say logarithm is exponent. So that will be negative 3 cross base is the base for this one. Okay. And for this one is 0 because logarithm is the exponent. Log base 2 to the 1. And then for this one, the logarithm is log base 2 to the 8. Okay? So you can see this 8 goes here, and this one goes here, and this 1/8 goes here. So whatever you have a positive number, a negative number, positive number, and a 0 here you plug in, you always have this place positive. So that's why we say the expression behind the log has to be positive. Okay? But the output can be positive, can be 0, can be negative. We want it to be, let me write negative here. Negative. For this one. Okay, here it is positive. Okay, so that means for logarithm, the output can be negative 0 or positive. But the input is always positive. Okay, so based on that, the first one, what is the domain then? We then should require that things behind the logarithm That's x minus 5 should be greater than 0. If x minus 5 is greater than 0, you plus 5 on both sides, you have a x greater than 5. X greater than 5 is from where? If here is 0, here is 5, then from 5 to the infinity. Okay? Then the interval expression will be from 5 to positive infinity. And 5 is not included, so here is round bracket. You may say round. Again, if it were square bracket, 5 is included. For the round bracket, we use a circle, empty circle, to exclude 0.5. Okay. Similarly, this will be a domain. So this is the domain. Now, from 5 to infinity. Now, how about this one? This one, we need to require 25 minus x squared greater than 0. Now, if you add x squared on both sides, you then have a 25 greater than x squared. Then you know would be what? The example would be 4 squared or negative 4 squared. 4 squared or negative 4 squared. Numbers smaller than 5 with absolute value. They all less than 25. Okay. So you want to write is what? The absolute value of x is less than 5. And then on the real number 9, if here is 0, here is 5, and here is 5, negative. Then all the points in between those 2 points, empty circle, will be in the domain. So then what is the domain? Domain is from negative 5 to 5. Okay? So that will be our second function. What is our third function? Third function is ln. Ln, you want to consider ln. Okay, you do not have to consider 5. That's a constant. You want to consider the sign expression behind the natural log. What's the meaning for natural log? This means what? This means log base is a Euler constant. On every calculator, it's 2.71828 something. So you have here is natural log 9x. That means that's log is e to the 9x. Okay. So then you wanted to have a 9x greater than 0. So both sides divided by 9. So you then have a x greater than 0. That will be the domain. So on the real number 9, you have a 0 here, and a 1 here, -1 here. So then from 0 to the right, 0 will not be included. Okay? Yeah, because the expression behind the log sign cannot be 0. Again, it's all positive. It's all positive. No 0 included. So the interval representation would be domain is from 0 to infinity. Remember, here is round. Round bracket. Do not include infinity. Okay? But 0 is also should be excluded. Alright? So, basically, that is the solution. Okay, I'll see you next time.